So here we're going to take the example of the frequency distribution we created in the last video and for the travel times. And what we're going to do is we're going to talk about some new concepts. We're going to talk about midpoint, relative frequency, cumulative frequency, and class boundaries. Okay, so how do we calculate these things? So the first one is the midpoint. The midpoint of a class is the sum of the lower and the upper limits of the class divided by 2. When I think midpoint, I think in the middle. Sometimes it's known as the class mark. Okay? So for the first class, what are the upper and the lower limits? That's 3 and 12. So I'm going to take 3 plus 12, and I'm going to divide by 2, and that gets me 7.5. Okay, so you go to your calculator, parentheses 3 plus 12, close parentheses, divide by 2, enter, you get 7.5. Okay, if you ever needed a fraction, all you have to do is hit the math frac button, and it would turn it to a fraction for you. Okay, so 7.5 is the first midpoint, right? What about the next one? Well, it would be 13 plus 22, lower plus the upper, right? Lower plus the upper divided by 2. So 13 plus 22 divided by 2 gets me 17.5. 17.5. Okay? And then we can keep going. 23 plus 32 divided by 2 equals 27.5. 27.5. I wonder if you see a pattern here. Okay, what's changing? It goes from 7.5 to 17.5 to 27.5. What's the next one going to be, you think? Yeah, it's going to be 37.5. What's happening? Literally, to get the next one, all you have to do is add the class width. The class width, if you'll recall from the last video, we calculated the class width to be 10. Okay? So you add the class width just like you did to get the next lower limit, right? So 47.5, 57.5, 67.5. It's okay if you didn't catch on to that. If you didn't, you're just going to have to do lots of those little thingies there, okay? So in general, the formula is the lower limit plus the upper limit divided by 2. Okay, that's the midpoint. Okay, now the next thing, is the relative frequency. So the relative frequency of a class is the proportion of data that falls into the class. So when I think of proportion, I think the percent, okay? So how do I calculate relative frequency? It's calculated as the class frequency divided by the sample size. And on your formula sheet, it's going to be F divided by N. Now, N, the sample size, would be found if I add up all of these frequencies right here. So I'm going to add all those up. And if I add all of those up, okay, a fast way to say this is to say this sigma F, which means to add up all F's. Okay, so that's what we're saying there. So we're going to sum this thing right here is a sigma. It's a Greek letter that stands for sum, okay? It's just a way to write add. So the sum of all the F's equals N, the frequency. The total totals, so all the data points added together is N. This letter N, we're going to use this letter N for the rest of the course, okay? That represents the sample size. The total of all the frequencies added together. And for this one, it adds up to 28, okay? So the relative frequency for the first, remember it's F divided by N. So that's going to be how many are in that class? It's 7 divided by 28. Now 7 divided by 28, that gets me 0.25. Okay? The next one is 6, because there's 6 in this class. 6 divided by 28 total. And so that rounds to 0.21. All right? If I do the next one, 4 divided by 28. 4 divided by 28 is 1/7. This reduces decimal to 0.14. Then I have 3 divided by 28. This is going to get me 0.11. 3 divided by 28 again gets me 0.11. 2 divided by 28 gets me 0.07. And then last is 3 divided by 28, which gets me 0.11 again. Remember, the 3 comes from the frequency in the class, and then the 28 comes from how many there are total. Okay, so there's always a total of 28. That's why I divided by 28 every time. Okay, so that number is staying the same throughout. The only thing that's different is the 7, which the 7 comes from here. The 6 comes from here. The 4 comes from there. The 3 comes from here. 3 comes from here. 2 from 2. And then 3 and 3 from there. Okay? And so what do we know? Well, if I was going to add all of the relative frequencies together, this would actually add up to, well, if you think about it as a proportion, all these decimals added together should add up to 1. Okay? So they should add up to 1 because 1 in proportion is 100%. Okay? So you might see that as a question at some point in the future. So make sure you got that down. The sum of the relative frequencies adds to 1. Okay, so the next definition is cumulative. Cumulative frequency of a class is the sum of the frequencies of that class and all previous classes. So the way I think about cumulative frequency is a running total. It's kind of like a basketball game. There's 4 quarters, right? You got the first quarter, the second quarter, the third quarter, and the fourth quarter. Maybe they score 10 points in the first quarter. Well, then in the second quarter, they score 20 points. So at halftime, how many points total do they have? At the half, okay, so after the first quarter, they have 10 points, but after the second quarter, they have 30 points, right? So maybe they score, 5 points in the third quarter, so that at the end of the third quarter, they have 35 points. And then maybe they score 15 points in the last quarter, and so by the end of the game, they have 50 points. These numbers down here are the cumulative frequency. Okay, so that's the cumulative frequency. Versus these numbers up here, these are the relative frequency. Okay? So the cumulative frequency, we add all the elements in the frequency of that class plus all the ones before it. So it's a running total, just like the score of a game. Okay? So let's do that. So the cumulative frequency here starts in the first class, we have 7. But the next class, we add 6 to that. So we take 7 and we add 6 and we get 13. Okay? To get the next score, I look at how many I scored in this one. I scored 4. So I take my 13 and I add 4 to it. I get 17. To get the next one, I take my 17 and I add 3 to it to get 20. The next one, I take my 20 and I'm going to add 3 to it to get the 23. And I take my 23 and I add 2 to get the 25. And then the last one I take 25 and I add my 3 to get 28. This last number here, if you did it right, will match how many total there are. Okay, once you add them all up, as long as you didn't skip some of the points, right, how the frequencies, then those two numbers will match each other. Okay, so that's the cumulative frequency. Okay. Now, this next definition is a frequency histogram. A frequency histogram uses bars to represent the frequency distribution of a data set. Okay? So, we're taking our data set, we're taking our frequency distribution, and we're putting it into a pretty picture. All right, so we're going to put this into a pretty picture here. All right? So I'm going to have two axes. Okay? So the first, the vertical axis, all right, so this up and down right here, this is going to be measuring the frequencies of each class. So this is F, the frequencies of each class. All right. So when I look at my frequency distribution up here, the biggest frequency I see is a class of 7. So I at least need to get tally marks up to 7. All right. So I go 1, 2, 3, 4, 5, 6, 7. I'm just going to go up one more to 8. Doesn't matter. As long as you get at least 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And now, what you can do on this axis, there's two options. The first one, I'm going to say, let's just call them the midpoints. So we can mark our classes by the midpoints, okay? So what are the midpoints? The midpoints are right here. They're 7.5, 17.5, 27.5, all the way down to 67.5. So this is the middle of each class. All right, so I'm going to mark it 7.5, 17.5, 27.5, 37.5, 47.5, 57.5, and 67.5, okay? And now what we're going to do is we're going to mark each one. So the first class had 7 in it. So I'm going to start at the first class, and I'm going to go up, and I'm going to put a dot at the 7. The next class had 6 in it, so I'm going to go up and put a dot at the 6. The next class had 4, so I'm going to put a dot here at the 4. The next class had 3, so I'm going to put a dot at the 3. And then we had 3 again. So I'm going to label these 7, 6, 4, 3, 3. And then I had a 2. And then I had another 3. Okay? So how do we do this? We're going to do this with bars. So I use bars to represent the frequency. So I'm going to make a bar here. Okay? And so my bars are going to split halfway in between the numbers. And now once I do that, I only have to go like this. And then I've got it. Okay? I'm going to cheat and go across down here like that because these are the same height. Then over and down. And then up and over. Okay, my bars, hopefully your bars are more straight than mine are, okay? All right, so this, my friends, is a frequency histogram. Labeled with midpoints. Labeled with midpoints. Those midpoints represent the middle of the class. Now, there is another way to label frequency histograms, okay? And so what I'm going to do is I'm going to copy this, right? I'm going to copy this and drag it down here. So I'm kind of cheating, all right? And I'm going to get rid of these little points here, okay? So the other way to do this is with class boundaries. Class boundaries. Okay, so how do I do it with class boundaries? All right, so class boundaries are a little bit different. Okay, so how do I find class boundaries? So what I like to do is I like to line up all my classes. So the first class was from 3 to 12. The next class was from 13 to 22. Then we went from 23 to 32. And then we went to 33 to 42. And then 43 to 52. Uh-oh. Let me pull this out a little bit. Okay, and then we have 63 to 72. So to mark the class boundaries, those are the things that separate the classes, okay? So to separate the classes, we need to find those numbers. So those numbers, all right, what is separating 12 and 13? It's 12.5, okay? What's separating 22 and 23? 22.5. These are class boundaries, okay? So what's separating 32 and 33? 32.5. Okay, 42.5 here. 52.5 here. Now what's over here? What would be over there? Well, if you see the pattern, what are you doing? You're adding the class width every time, right? So this is going to be what's 1/2 greater than 72. That's 72.5 right there, okay? And then on this side, what do I put over here? Well, it's got to be one less than this where we started, right? Just like it's 1 or 1/2 point less over here. Okay, so what is that going to be? That's going to be 2.5 starting right there, okay? So my boundaries, first one, 2.5, then 12.5, then 22.5, 32.5, 42.5, 52.5, 62.5, and 72.5. So this would be a frequency distribution, okay, labeled with class boundaries. Okay, labeled with class boundaries. Now there is a formula, but to me personally, I think it's easier to just line them up like this and then write the numbers that are in between. That's my personal preference, but there is a formula. And to get the lower boundary, what you do is you take the lower limit of the class and you subtract 0.5. To get the upper boundary, you take the upper limit and you add 0.5. So if you're a formula person, here's the formula for you, okay? If you're somebody that's like, okay, give me the easiest way to remember how to do this, personally to me, I like to line them up and then write out the numbers that are halfway in between the classes, okay? So that's how I do it. It's the numbers that separate the classes without forming gaps between them. You notice there are no gaps in between this class rectangle and this class rectangle. You see, none of the rectangles have some gap between them. Okay, there's not some space in the middle there. Okay. Now, if I'm going to write out the frequency or the class boundaries, so it's going to be 2.5 to 12.5, and then 12.5 to 22.5, and then 22.5 to 32.5, 32.5 to 42.5, 42.5 to 52.5, 62.5 to 7, I'm sorry, messed up. 52.5 to 62.5, and then 62.5 to 72.5. Okay? Now, you might be saying to yourself, well, Mr. Clark, didn't you say that these classes can't overlap? Well, that is true. The classes don't overlap. The class boundaries, though, The boundary, you think about the border to a country. If a country shares a border, both countries share that same fence, right? So you think about like a property, like a backyard, the backyard is divided by that same fence, whether the neighbor likes it or not, right? So you don't have to, it's okay to have the same upper boundary as a lower boundary for another class, okay? So for that first class, the upper boundary is 12.5, but for the second class, the lower boundary is the same 12.5, okay? And that's okay, all right? One other little polygon thing going on here. So let me go ahead and copy this picture, because this picture seems to be the best one to copy. Okay, I'm going to duplicate this. I'm going to bring it down. Okay. There's another way to do these problems. Let's see if I can get all these out of there. Delete. Okay. One less. All right. So this is known as the frequency polygon. The frequency polygon. Okay. So the horizontal axis are the midpoints, and the vertical axis are the class frequencies. Okay. So this one starts at 0. Okay, it starts at 0. And it goes up to the 7. And what we do is we just connect the dots and we make a polygon. Okay? So we're literally connecting the dots here. Right? And then we go back down to 0. Okay, so we start at a frequency of 0 and we end at a frequency of 0. Okay? And so we make a polygon just like that. All right? The emphasis here is that there's continuous change going on with those frequencies. All right? So it starts on the horizontal axis and it finishes on the horizontal axis. Okay? I mean, technically, this first value here, look, what are you doing? You're adding 10 to go this way, right? So to go that way, you subtract 10, so that technically would be like a negative 2.5. Okay, I'm not going to be a huge stickler on that. And this would technically be like a 77.5 over here. Okay? Same thing, you can do this graph again. Let me take this graph, do it again. I know we just keep copying the same thing over and over, but I'm showing you all the different things you can do here. So instead of this being frequency, okay. Oh. All right, I thought that might do that. Okay. So instead of that being the frequency there, what this is now, this is a relative frequency histogram. Okay? So a relative frequency histogram turns this into the relative frequency. So we go back and we think about what was the relative frequencies. Well, the first class had a relative frequency of 0.25. The second class had a relative frequency of 0.21. Look, if you go all the way back here, you'll see the relative frequencies. Okay? And then we had 0.14 and 0.11, 0.11, 0.07, and 0.11 again. Okay? So this would be an example here of a relative frequency histogram. Okay? So maybe you can make the conclusion, looking here, it looks like a ton of data fell in that first class. Well, if you think about that first class, what was it? It was from 3 to 12, right? Okay, so you could say like 25% of the population takes 3 to 12 minutes to get to work or school or wherever they're going in that problem. Okay? So that would be a way to interpret that first class there. Okay, that 0.25, that relative frequency. Remember, if you add up all of the relative frequencies, you should add up to 1, which is equal to 100%. Okay? Now, there's another graph. It's called the cumulative frequency. Okay, so the cumulative frequency, we'll just draw a whole nother one for this. Cumulative frequency graph. What does this look like? So we've got a horizontal and a vertical axis. So the horizontal represents the vertical represents the cumulative frequency. So how many did we add up to? We added up to, I guess we added up to 28. So I need to at least make 20 go up to 28. Now, if you want to put 28 tick marks, be my guest. I'm just going to put 3 and count by tens. Okay? So if you want to go all out, go for it. All right? Now, the horizontal axis, these are the upper boundaries of the class. Okay, so you think about the upper boundaries of the class. The first upper boundary, I believe, was 12.5, right? And then it was 22.5. And so that means at the 0 mark, that was the 2.5. Okay, so, and then we had 32.5, 42.5, 52.5, 62.5, and then 72.5. Okay, so before we start any data points, the smallest amount of time was 3, I believe. I think 3 was the smallest, and then 72 was the largest. Okay, so at 2.5, there's nobody that's cumulated. Now, at 12.5, after the first class is completed, we have 7. After the second class is completed, we have a total of 13. And after the third class is completed, at 32.5, we have a total of 17. And then we work our way up to 20, and then to 23, and then to 25, and then finally to 28. Okay? So, and then we connect our dots. Okay? And this is the cumulative. So the one thing to notice about this, okay, the cumulative frequency graph, is that we're always going up or over, right? We're never going down. We're never decreasing. This is a non-decreasing graph, okay? Meaning that we either have to be equal to the next number or greater. Okay, we either have to be equal or greater, right? Every one of these are greater. But if you had a class that had nothing in it, then that next one would just be like, that would be like 20, right? It'd go from 20 to 20. There'd be no growth. But all of our classes have elements in them, okay? That's why each one is increasing, okay? So you might be asked, what is the greatest increase? Well, the greatest increase jump looks like it's between the first class, where we jump up from 0 to 7. So this has a +7 increase. This next one has a +6 increase. This one has a +4 increase, +3 increase, +3 increase, +2 increase, and +3 increase. So I would say that the first class has greatest increase. Okay? Excuse me. All right, so the horizontal axis is the upper boundaries of the class, and the vertical axis is the cumulative. Now, another name for the cumulative frequency graph, which you will see, is the ogive. Okay, so the ogive, that's another name for this cumulative frequency. It's the ogive, okay? So it's used to describe the number of data entries less than or equal to a certain value. So you start at the lower boundary of the first class, and then you work your way up, okay? The point of all these graphs is so that we can summarize and put the data into a picture. That way we can extract the information quicker. All right.